answer some of these questions. Doesn't carbon-14 dating prove evolution? Well, there's two questions here. There's really two. Carbon-14 itself, which is a particular method, and the whole concept of radiological methods in general about don't they demonstrate the Earth is really old, not young. Well, to do a little justice to this, I've got to cover little things in the background. First of all, how do you tell how old something is? Well, you look at a process, some kind of process. For example, if we wanted to guess how old the Mississippi River Delta was, we'd watch the flow of the water. We'd look at the mud accumulation and we'd try to take a guess in terms of how long the process had taken place. So we observe a process, we measure it, we assume certain things about the past, and then we calculate the amount of time to bring us to the present. That's a great method to do something, except there's problems because you made some assumptions here. And assumptions can be right or wrong. If I measure the Mississippi River and I measure it in a flood year, I'm going to get erroneous results about the delta. If I measure it in a drought year, I'm going to get erroneous results about the delta. I've got to measure it in an average year, and what's an average year? We don't know. And measure a number of years, maybe you'll get better, but you still make these assumptions. And to do this, measure something, you've got to measure units of time. You've got to have a clock that isn't reset. We can't have the formation of a river delta and then have a huge flood that tears the whole delta away and starts us over, because then we could never tell how old it was. So it's got to be no reset. It's got to operate in a closed system. Outside things couldn't influence it. We couldn't have, for example, a backflush from the Gulf of Mexico coming back up the river and carrying things back upstream. That would hurt us also. It has to run constantly. The rate has to be the same. And we have to know when we started. After I told you those requirements, I'm going to tell you something else. There aren't any clocks on the Earth that work that way. Everything has to make assumptions. Everything has to be used in some fashion, so we always are uncertain how we can do it. So carbon-14 itself, this is the process. It's created in the upper atmosphere by cosmic rays. Cosmic rays coming in from outer space are bombarding nitrogen-14 and converting it to carbon-14. Carbon-14 is naturally radioactive. So when you eat food, carbohydrates for example, you eat some carbon-14. Some of that carbon-14 goes inside your body, and your body is slightly radioactive. Okay? You don't glow in the dark, but you are slightly radioactive. So you're carrying around this carbon-14 in your body, you're absorbing it, and you're in balance with your environment. Okay? You're kind of in balance with how your environment is. And then you're at the same level. Now you die. You stop eating. The carbon-14 begins to decay, and nothing new is added. So if we measure how much is left in something that's dead, we can tell how long ago it died. Because we know how much it should have and how much it has now, and we can calculate how long that time is because we know how rapidly carbon-14 decays. That's a pretty good method. Okay? It works reasonably well. But, here's the but. You have to have bone or tissue or bark. You can't have a fossil. A fossil is a stone picture of a bone. It's not the bone itself. Therefore, you cannot measure fossils with carbon-14. You only measure bones. And finding bones buried is exceptionally rare. And we look at the record of things we find fossils, and fossils are stone pictures. So that's the first problem, is we can't measure most fossils with carbon-14. The second thing is, carbon-14 was only good to 50,000 years anyway, because after 50,000 years, it's all decayed. It's gone. There's nothing left to measure. So that's the end of the clock. So it doesn't measure millions of years anyway. So carbon-14 doesn't really help evolution, first of all because you can't measure almost everything you want to measure, and the second reason is because even if you could, it's only good to 50,000 years, and evolution needs millions and millions of years. Now, there are other radiological methods that are used, potassium, argon, uranium, lead, there's a whole series of other methods, and I'm not going to spend much time on those, but let me just cite a couple things about them. Those methods are based upon a rock that has had a change of state. Okay? The way you use the clock is, like the carbon-14 was, when the thing died is when the clock starts. Well, the clock starts on the other radiological methods when the liquid lava, the liquid rock, turns solid. It's called a change of state. Right? That's when the clock begins. Which means that the only rocks you can measure with those methods are rocks that float out of mountains in liquid form. Therefore, you can measure no fossils, because fossils are not trapped in lava. Fossils are trapped in sedimentary rocks that are laid down underwater. So you see, the radiological methods don't help evolution at all for those two reasons. You can't measure most of the stuff, and even if you can only measure the lava rocks. For example, when Donald Johanson found Lucy in Africa, He said, how am I going to date this fossil? Well, he found a lava flow about 1.5 miles away, took that lava flow and measured it, and tried to extrapolate it to the date of the fossil. He had to do 3 tries before he got the answer he wanted, and the way he got it the 3rd time was simply to tell them what he expected, and then they got the answer he wanted. That's not good science, ladies and gentlemen. But, in fact, that's the way it works, so that's the problem. The second thing about carbon-14 that's really interesting to us is this. If evolution were true, carbon-14 should be in balance in the atmosphere. I mean, if it's been here for billions and billions of years, the carbon-14 should long ago have come into balance in the atmosphere. In fact, the carbon-14 is not in balance. It is still seeking an equilibrium, which would indicate that on the curve, that the rate of it, that it goes back somewhere about the time of Noah's flood. Exactly what you'd expect based on the creation model. So carbon-14 is not in balance, and the fact that it's not is a significant indication of a young atmosphere. Those other radioactive methods I referred to, just a couple other things. You have to assume constant decay rate. You have to assume that nothing has come in or gone out of the rock, and that's a big assumption because uranium salts, for example, that are commonly used to measure, are extremely soluble. They flow in and out of rocks all the time based upon the movement of water. So these assumptions that we make in radioisotope dating are also assumptions that are extremely tenuous, at least. Steve Austin at ICR measured a series of fossils, measured a series of lava flows at Grand Canyon. He took the lava flow at the basement underneath everything, and took the lava flow that's on the very top, that flows over the rim and down into the canyon, and measured it by 4 different methods. And what he found out is simply the scientific conclusion was the canyon's upside down. Because the basement rocks were younger than the rocks on top, indicating really that the methods don't work. The methods are not successful in determining real ages. Okay, let's go on.